class and name product you like. I need $1 million investment.
Okay. Let's look at some of these tests. I put the link in resources, by the way. So you guys, I just updated this link at the beginning of the session. All right, final spring 09. How about that? No, final fall 08. That's close enough.
Don't panic. Don't panic. That's like
It's your time to
just
choose.
Thank you.
That's what I thought the first time I saw that. The answer to everything.
Bring your test. Take your time. This is not a race. Write your name 3 times.
All right, we're going to skip over like the search ones, and
That very satisfying.
we didn't do constraint satisfaction problems. So. All right, here we go. Imagine you have 2 slot machine levers. We're playing a game where each time step you must pull exactly 1 lever. Lever A always pays a reward of 6. Lever B pays a reward of 10 or 0. If B is a lucky lever, it pays 10 with the probability of 4/5. If it's an unlucky one, it pays 10 with the probability of 1/5. B is equally likely to be lucky or unlucky off priority. Assume gamma equals 1.
So lowercase l is 0.5?
I'd say you can kind of ignore the 1/2 and just go right to the other probabilities.
Yeah, lowercase l is 0.5. Yes. Well, it looks like it's a logical thing, though. But the likelihood of it being capital L is, yeah. Assume gamma equals 1. Okay, so that means there's no discount on the rewards. If you can only pull a lever once, what is the maximum expected utility? Oh, that seems like a good problem.
You're just calculating expected value based on probability?
Sorry?
You're just calculating expected values?
Yeah. So you're only play the game once. What's the value of the game? So let's model it in terms of like an MDP.
A is 6.
So it's an MDP. You're in step. You're in the first time step. You've got 2 places you can go. So your actions are you can either put your actions are A and B. Okay, A is the sure winner, and your reward is 6. B is the lucky or unlucky one. It's got 4/5 of the time, if it's lucky, it will pay 10. And we know that half the time it's lucky. So 4/10 of the time, this will give you a 10. And then the rest of the time, 6/10 of the time, it will give you a 0.
Is that what it said? 4/10?
It said 4/5. It said 4/5 of the time. If it's lucky, it will 4/5 of the time give you 10. But then the other information I'm including here is half the time it's lucky.
Oh,
Yeah, but when even if it's unlucky, it can still give you a 10.
Yeah, that's true.
Yes, you're right. Okay, maybe we should model this one as, let's try again. All right, if we pick A, we know we're getting 6. If we pick B, then there's actually 2 different ways it can go. So it can go to the lucky B, or it could go, this is like a Q state where then, yeah, I'm gonna try one more drawing on this.
You could,
I mean, I think there's different ways to come up with this answer, but I think the closest model is, okay, if you pick A, then you definitely go to, so these are your actions. Your action is A.
I see it.
Okay, thank you. You pick A, you go to the state which will pay off the 6. If you pick B, you will go to a state where then there's two other possibilities. And this is lucky B, and this is unlucky B. Okay, and there's a 0.5 of each of these. This is the B choice from your start state. And the lucky B is 4/5 of the time it's a 10, and 1/5 it's a 0. And the unlucky B is always, if it's unlucky, oh, then it's 1/10 of the time, yeah. Or 1/5, sorry. Okay. So I guess what we're trying to do is figure out what's the utility of B, and then we can decide which of them is better. So has anybody already figured it out?
3 for B.
Well, B is 5.
What?
B is 5.
Well, I mean, if you get lucky, then the expected value is 4. Oh, sorry, it's 4/5 is 0.8, it's 8.
Right, this one's like worth 8. And that one's worth 2,
If you're unlucky, the expected
right?
value is 2. You have half of 8 plus half of 2 is 5.
Okay, I buy that. Okay, so then the value of being in the initial state is 6. Because you'll pick the best one. If we go back to the setup.
So you should pick A.
Yeah, you should pick A. In fact, you should always pick A.
Guaranteed rewards are nice.
Expected value.
There's no risk in it either. Do you have the solution
You
as
should
well?
necessarily always pick A. Just if you can only go once, you should pick A.
Uh-huh.
But if you can pick more times, then you can try to explore if B is lucky.
Oh, if you don't know
Right.
if you don't know the weights of how often you're gonna get lucky
Well,
lucky B.
Not even that.
Yeah.
Because you can check if B is lucky, and B is lucky, it's going to stay lucky, and it's going to stay better than A.
Oh, right. Either you're dealing with a lucky B or not.
Right.
Yes.
But we only have one poll, so that doesn't matter.
What does the question mean? It's mean by both. If you're only pull one.
Right, that's what it says.
Which value gives the max expected?
Yeah, what does it mean by both?
They could both have an equal.
Oh, I see. I think you pull both at the same time. That's cheating.
Yeah, so, all right, so we believe the answer to question B is A, right? And now we're on to this next thing. If you can play this game multiple times, it becomes more difficult. The game is formally we didn't really go over these, partially observable Markov decision process. But we can turn into an MDP where the states encode our past actions from lever B. In particular, a state will be of form Mn, where M is the number of times we pulled B and got 10, and N is the number of times we pulled B and got 0. We begin in state 0, 0. We pull lever B and get the outcome 10, we'll go to the state. So they're giving you the representation here. Play exactly 2 rounds and work it out. All right, I think that's not that difficult. The resulting payoff should, here's what Michael's getting at, should change your beliefs about what kind of lever B is, and therefore what future payoffs from B might be. For example, if you get the 10 reward, your belief that B is lucky should increase. If you're in state 0, 1 and select action B, list the states you might land in and the probability you will land in them. Let's do that one. All right. Yeah, you're in state 0, 1. I'm going to switch back to Dr. Cam. Okay. You're in state 0, 1. So what does that mean? To be in that state?
0 plus 1, right? Or no,
You chose B.
It means you chose B and you did not get the reward. Right? If it was 1, okay, so now if you were in state 0, 1 and select action B, list the states you might land in and the probability you will land in them. Well, there's only 2 states you can end up in. You could either be, you got a reward, or you could end up the state where you didn't get a reward. And now, do you know that you've already lost at this point?
You know, you're in that state, so you have that information.
I think, so then it's just, this is a, going back to the other diagram, which is the right one. Going back to this, your chances of getting the reward are 5, they're 5 out of 10. You still don't know if it's lucky or unlucky.
You have an idea.
Because you have an idea because you didn't get lucky the first time?
Yeah, right. So if you look at the probabilities on that other sheet, the first one,
Yeah.
so there was a 1/5 chance that that lever was lucky and you still ended up with 0, whereas there's a 4/5 chance that the lever was unlucky and you ended up with 0. So that's what you know about where you are. So you're 80% sure you're unlucky.
Say it again?
So you got a 0.
Yeah.
So if the lever was lucky, there's a 1/5 chance that would happen. And if it's unlucky, there was a 4/5 chance that would happen.
Right. So at this point, our belief is 4/5 that we're unlucky.
Right.
Okay. So then, using that knowledge, we can figure out our expected likelihoods of getting into each of these two states. So if it's 4/5 of the time, it's unlucky, and then it's even more likely that this will be the case. So what's the product there, though?
4/5 times 4/5 plus 1/5 times 1/5. Yeah.
Let's write that as 0.8. Plus, there was, right, a 0.2 chance that we thought it was unlucky, but actually it was lucky. And then in that 0.2 chance, there's a 0.2 chance that we'll be unlucky again. And so this one is 1 minus that other thing. So that's what, 0.64 plus 0.04. So this is 0.32. Yeah, okay, we should see if we have the answers here to check our work.
You're good so far.
Hmm?
You're good so far.
Oh, you got the answers, good.
Are we really?
Yep. Should be 0.68, yeah, you're good.
If you're in state 1, 0 and select action B, this is just the same problem. That's annoying. Like, as it, you know, either you understood what you were doing or you didn't, and you're not going to learn anything by doing this. Except maybe they both factor into the next one. On the computation tree in C, clearly mark the probabilities in each branch and any chance of nodes. What was C again? Oh, we didn't do that, we skipped over it. Draw the computation tree which represents the outcome. Well, all right, go on. Again, this 2-round setting, what is the maximum expected utility from the start state? So this is just playing this thing out. If the number of plays n is large enough, the optimal first action will eventually be to pull lever B. Explain why this makes sense. All right, well, I think we unpacked this one. It's a good problem. Let's see if we can find one on Bayes next. Yeah, all right, let's do this.
Next one. How'd you do that?
Okay, let's do this one. Okay, so there are 2 types of conditions, sinus congestion and flu. Some congestion is caused by allergy or the flu. There are 3 observed symptoms for these conditions: headache, runny nose, and fever. Runny nose and headaches are caused directly by sinus congestion only, while fever comes from having the flu only. For example, allergies cause runny noses only indirectly. So, okay, assume each variable is Boolean, so it's true or false. Which of those describe the thing that was just presented in words?
It's not 3.
Yeah, it's not 3.
It's 2.
Why not? Why is it not 3?
Because going
Runny
across
nose is
directly
directly-
sinus.
Yeah, runny nose is directly influenced by allergy. Not true.
I see.
Yeah, okay, so that last statement is contradicted by 3. So we can't have a link from allergy to runny nose, because is that the only one that's like that?
Yeah.
See, that's the thing. You could know nothing about this problem, absolutely nothing, and about this thing of multiple choice tests, right? And notice that that's probably the wrong answer, because that one bit of information is, you know, you're sort of guessing the way the test would be designed anyway.
I don't know.
That's playing the test out.
Yeah, but that's like a huge problem with all of these multiple choice tests. Everybody knows, people who are smart students know this.
You know what's the easy way to circumvent that problem?
Throw that one out, like, so
Guess around.
you could, if that was just all you knew, you'd throw out, all right, anyway.
Just do the final write-up and the final project and call it a day. No final test.
Stop it.
Stop it.
Okay. Runny nose and headaches are caused directly by sinus congestion.
Two.
So which one of them says that?
2.
Yes.
Wait, runny nose and headaches are caused by sinus congestion only. Runny noses are, yeah, right, so with 2, runny nose and headaches are caused by sinus congestion only. And while fever comes from having the flu only, fever is V, yes. So far 2 is a good candidate. All right, I think, we know what we're doing here.
Yes.
All right, next one, B. For each network, if it models the domain exactly as above, right, correct. If it has too many, wait a minute, is this just like pushing on the same thing again?
It just says state why it's wrong. It's wrong.
Oh, either it should have either has an extra independence or it has a missing independence.
Yeah, that solves your multiple choice concern.
Yeah, that's true. Okay, so what's wrong with number I, letter I?
Sinus congestion doesn't cause flu.
Yeah, the flu has to
Which
cause a
could be
sinus.
extended out to
Yeah.
allergies don't cause flu.
Right, right. Letter I says sinus congestion causes flu, and it's the other way around, is that flu causes sinus congestion. So then what are we supposed to write there?
Apparently A perpendicular sine F.
What?
A perpendicular sine F.
That's what the answer is.
The answer is a perpendicular sine.
No, that means something.
Oh, okay, what he wrote down there here was,
I see. I see.
sorry, I wrote it badly, so it's the sort of thing where actually handwriting matters. This is the answer to that. So that means A is conditionally, it's either independent or conditionally independent of F.
If you gave us this question, we could just write it out in words and you'd accept it, right?
Yeah, we didn't really deal with this symbol.
Thank you.
Looks like
Alpha.
I think with the multiculus one.
Yeah, we know, we got that 2 minutes ago.
We can keep going for another like 15 minutes. We have to clear out because there's an exam in this room at 11:30.
Coastline. With HMN.
We didn't really deal with those enough. Like, I might ask some general questions about, but we didn't, I don't think we dealt with them enough.
Yeah, we didn't deal with them that much. Yeah, it touched upon something.
We talked about them in class, but you guys like didn't do anything. Let's do this last one. All right, so we want to remove the sinus congestion node. Draw the minimal Bayes net over the remaining variables which can encode the original model's marginal distribution over the remaining variables. All right, let's get the... This basically assumes you know what you're doing at this point. We want to move the sinus node. Well, the correct one is that... I'll drop it down, then we'll go from there. It's so much easier to like deal with the drawing than the text. Right, isn't it like just much easier to like look at that and see what's going on once it comes up? Right, flu causes virus, right? Fever, V is fever. Flu causes sinus, S is sinus condition, sinus congestion. Sinus congestion causes headaches. Sinus congestion causes runny nose. Allergies cause sinus congestion.
So we're supposed to get rid of S?
Yeah, so everything that goes to S goes to whatever S is pointing to.
Yeah, let me read the problem. Assume we want to remove sinus congestion node. Draw the minimal Bayes net over the remaining variables which can encode the original model's marginal distribution over the remaining variables. Yeah, it's, I mean, do you just point at, so S is gone, so then
So F points to H?
And R.
you're looking at the answers, right, a lot?
Yeah, sorry, I was talking.
That's okay, no, I mean, that's good you're doing that. Well, clearly fever still, flu still causes fever. So then flu causes headaches,
And
Flu causes runny nose.
allergies cause headaches,
And they both cause runny nose.
and, oh, flu also causes runny nose,
Yep. And allergies.
And allergies.
and allergies cause runny nose.
There's
And then-
one more tricky one.
That's a tricky
And
one.
then
Yeah, there's
allergies, wait,
R goes to H,
Or H goes to R.
either way.
H goes to R.
ah.
Yeah, it says, please note there's
It's-
an
yeah,
induced
it's
arrow
given
between
to
R
you.
and
Wait,
H.
let's let read it.
It just says, note that there's an induced arrow between R and H. You can choose either direction.
What? Either direction?
Yeah, so you go from R to H or from H to R.
I know what it means. but Why?
Right, so why is that true?
Did you just tell me R and H?
So you can basically do this
Yeah.
or the other way.
How?
Right, so what, think that, why does that make sense?
Isn't that given because you have a sinus condition, you have both R and H?
You may.
Whereas the model we had previously, A could go to R or A goes to H. It's not necessarily both.
I mean, this doesn't have to, does this have to do with A at all?
No, but if you end up with a sinus infection, that causes both a runny nose and a headache.
Yes.
But without this new arrow here,
Right.
you could have ended up with just a runny
Just one.
nose or just a headache, and that would not be consistent with the previous diagram.
Nice.
I never would have done
Yeah.
That's just tricky.
Yeah. Cool. Why don't we do one more of these Bayes ones, and then we'll say we're done.
that. What about society mind? This is society.
No, that's not gonna be fun. We're done with that. We're done.
Spell
I could quiz you on what he said in class.
God doesn't exist.
It all starts with a fish.
Oh wait, there's more stuff on
Yeah,
here.
it's funny.
Let's see if we have the if we have what we need to do this one.
It's the guy from Bob Jaguar.
Oh.
No, I don't.
The Chewbacca attending the demonstration.
What?
Because of the Chewbacca, attending it.
Oh yeah, Jabberwock. You've been put in charge of a Jabberwock for your friend Lewis. The Jabberwock is kept in a large Tugley wood, which is conveniently divided to an n-by-n grid. It wanders freely around the n-squared possible cells. At each time step, Jabberwock is in some cell. Okay, so there's your like hidden part of the state. He's in some cell X of the set of possible states is within, it's in the grid. And he moves to another cell randomly with probability of 1 minus B. It chooses one of the up to 4 valid neighborhood cells and moves uniformly at random with probability E. It uses its magical powers to teleport to a random cell uniformly. and it could teleport back to where it started. Assume E equals 0.5, N equals 10, and the Jabberwock always starts at x1 is like the state of possible places he can be. So at the set. So at that time, step x1, there's only one place he can possibly be. Compute the probability that the Jabberwock will be in the next time step will be at x2 equals 2 comma 1. 75%? That was quick. I guess you already saw that as I was reading. Well, oh, half the time he tries to move,
He gets there.
and that's an adjacent cell.
Half the time he
So half the time he gets there, right? And then half the time he teleports, though, and if he teleports, he could be anywhere.
So
Well,
maybe
it's
it's
100 cells.
Yeah, maybe it's 50 times 1 in 100.
Yes.
It's
1/2
51.
squared plus 1/2 time.
That's my guess.
Yeah.
Well,
51 out of 100.
Well, no, it's half the time you move to what you want, so that's 0.5 times you did it. And then if you do teleport, one in n squared chance you hit where you want.
Yeah.
And then it's 10 is 1 in 100.
So it's 0.51.
Or maybe it's not.
So it's 0.5 times 0.1. Or plus 0.1.
Plus, right? 0.0, I mean, it's
Oh, yeah,
0.01.
sorry,
It's
0.5
squared.
Oh, but half the time he's going to teleport. And then the likelihood of him ending up there if he teleports is 0.01, so it's 0.505.
5.1. Isn't it just 0.51?
What?
0.255.
That's what I was going to say. It might be 1/4.
if you're at 1-1, there's only 2 possibilities to move. Half the time you'll go to 2-1.
Oh, right,
With half of the probability. So
Right.
that's half times a half.
okay.
Plus
So it's
1/2.
0.25 plus point,
0.005.
0.0, so it's 0.0255. Is that what it says?
I've got it in the 0.0255.
Correct.
Okay.
Should be
it's
no
point-
zero.
point zero- 0.255.
Yeah.
That's right?
Yeah.
Okay, good. Next
We'll go
one.
full for that.
What about the probability at time, at step 2 that he's at 4.5?
That should be
That's
one
a
of
lucky
the
teleport.
0.005.
Yeah, 0.05.
0.005.
Lucky teleport.
Lucky teleport. Okay, good.
Yeah.
Keep going.
It's 1/2 times 1 over 100. Because between the time it'll teleport.
Oh, that's just where you write in your answer.
I'm sorry.
Okay, at each time step t, you don't see x of t. That's the set of possible places where you can be. But you see e of t, which is the, so that's the emissions, which is the row that the Jabberwock is in. If x of t equals r comma e, then e of t equals r, row comma column. You still know that he starts at 1, 1. Okay. Suppose we see that evidence at time step 1 equals 1, evidence at time step 2 equals 2, and evidence at time step 3 equals 10. Fill in the following table with distribution over x of t after each time step, taking into consideration the evidence. Your answer should be concise. You should not need to do any heavy calculations. All right, let's do the first one of those. So the evidence is basically which row he's in. So evidence of time step 1 equaling 1, that's just because he starts at 1, 1, so that's a given. Evidence at time step 2 equals 2, then we know he's in row 2, right? This is like deterministic in terms of the row. And evidence at time step 3 equals 10, he clearly teleported. Okay.
All we know at time step 2 is that he's 1 cell away from where he started. He could have gone to either 1, 2 or 2, 1.
No, isn't it that? Doesn't it mean that?
1, 2's not row 2.
Yeah, that this line here.
Yeah, E2 equals 2, so it has to be
Yeah.
2.
Yeah, like, right? So he's got to be in row 2. So R has to be 2. And this one's unusual in that, like, the evidence is, you know, it's not probabilistic. It completely gives you one of the two state variables, rather than probabilistically giving you something, some information. It tells you for sure that you're in row 1, you're in row 2, you're in row 10, right?
Just looking at the solutions, they have like both of those two coordinate points, like 1, 2, and 2, 1, both listed for the
Really?
red spot. Yeah.
All right, let's look at the answers together. So, here, which one was that?
Follow 8.
Follow 8 solutions.
Is page 11.
Okay, the probability of what's the set x of t given the evidence that's been accumulated since the start of time. So, yeah, okay, so all right, that first cell is it's a 1.0 probability that we're in state 1,1, anything else is probably 0. What's the next column? That's, the first column is given evidence up to the previous time step. So this is like basically the thing that we can go back and know more about what happened. So like here we're filling in what's the likelihood of, here we go, this is the cell you were looking at, Eric, right here? Yeah, the reason that we don't know where we are so much is because we don't have, this is the evidence up to time t-1. So we don't have the evidence of row 2 yet. So we don't know where he is. He could be in 1, 2 or 2, 1 or anywhere else in the world with the teleport. Right, because it's the t-1 there.
The next column is the same answer.
Why is it
Oh, it's only
51?
one in my.
Okay, so let's look at the last column.
Why is it 51?
Because there's some teleporting going on there, right?
I believe
The same possibility.
It's basically without the teleporting, the likelihood of that, isn't that, would it be 1/2? Without teleporting, that's in one of those two states?
Well, you can teleport to that state, the state that you can move 2 days with. And since it's only half of that anyway.
Oh,
No, but why isn't
no,
it?
each 1, 2, and 2, 1 each have a 51/200 chance, right?
Oh, okay, that's where it is.
So
That's right.
each one has a 1/4 chance of getting there, plus
Right.
a 1/200 chance of teleporting there.
Right, right.
That makes sense.
Okay. Yeah, I was looking at this set together.
Yeah, I was impressed too.
0.255 just as a fraction.
Yeah, that's right. That's the
Yeah, each of
0.255.
those two states has that probability.
Okay, so let's look at this one. So this is where we know he's got to be in column 2. So the probability of that one,
So you could have either moved there, which would give him 50 out of 200, or you could have teleported there, which would give him 1 out of 200.
right? And the other ones are each of the teleports. Why does that not add up to 1? Oh, I guess when you add up all these, well, there's only 10 of these, or 9.
No, there's like 98.
Yeah, 90.
Because you know it's in
99
row
too.
2.
Yeah.
No, this can only go from 2 to 9 here.
Oh, right.
Yeah, that's right.
Well, there can only be 10 things he's in then, if he's in row 2. That's still what's happening.
But he can't be anywhere else.
Yeah,
He can't be in row 1 or any other row. He's got to be in row 2.
yeah, I agree. Why does it have to add to 1?
Yeah, shouldn't it have to add to 1?
Maybe they left it normalized for some reason. Yeah.
Oh, it's just not normalized. Yeah, I think that's right. Yeah, you could normalize it. Yeah, that's got to be what it is. It's not normalized.
So this is going to not be on the final? Or
No, I think we should be able to deal with this.
I don't know.
Yeah, this question.
So the total was 60, and then you're normalizing it.
I think we should be able to deal with this.
Part A was fine.
51.
We're gonna have the answers when we have to do it on the final.
If we're struggling, we're looking at the solution, is that really a valid question?
It's a little bit over 5, 6. Yeah. We just normalize it that way.
You were a bit unsatisfied that you can't pinpoint the Jabberwock exactly, but then you remembered Lewis told you Jabberwock teleports only because it is Frumius on that time step. And it becomes Frumius independently of anything else.
What did you just call it?
Frumius. So do you know what that means? I don't know what it means, but there's so
You're the
much.
one with the
Frumius.
You're the one with the PhD. What does it mean?
Let us introduce a variable, the likelihood of Frumiousness at a given time step is between 0 and 1, to denote whether it will teleport at time t. We want to add these Frumius variables to the hidden Markov model. So there's two different ways we could model Frumiousness. Okay, so basically Frumiousness is a hidden state.
That makes sense.
And so the A thing is showing that Frumiousness affects which state it's in, and then which state it's in affects the evidence variables. And the model B shows that which state it's in affects Frumiousness and also affects the evidence variables. For each model, circle the conditional independence assumptions which are true in that model.
I hope it's A.
I think this brush over our heads.
Yeah, this one's, do they ask you to choose which one is it? I think it's B.
B would mean that.
But it actually, it says it becomes Frumius independently of anything else.
That would.
Which leads to Fermius leads to E. So F leads to E. So doesn't that mean A is
Yeah,
correct?
Yeah, I think because B would say that Frumiousness 2 is affected by x1 and x2, which doesn't make sense. Part A says all the Frumiousness is independent.
So part B says that Frumiousness depends on which series of states it went through and which state it's in.
It definitely seems.
And right, and A says that they're independent. They're independent variables.
He either is or isn't Frumius, and then he either does or doesn't teleport.
Yeah.
He doesn't.
Yeah, I could see us, we should be able to deal with number B there. Sorry, D at the bottom. So is A the answer?
I hope so.
Oh, I guess we just flip down.
I love how I hear it.
Yeah, now we should be able to do this translation from text to Bayes networks. And I mean, I think the level of understanding for the HMMs that I'm looking at is this idea that there are these hidden variables and evidence variables. And so I think what we just went through is appropriate.
I just want to get a quick note on, kind of in serious context. We all did, the first exam, and most of us for our projects, we went to search in depth.
Yeah.
We got more of an understanding. So do you think, it sounds like you said this might be unfair for people that didn't do well in the first test. So I was just dividing the test into search and then the second half. And whoever wants to do the first half can. Otherwise, you can just focus on the second half. Because I think we all got a good understanding of search, during the first exam and our projects.
I'd like to have the final be on search.
But then, but I didn't record, sorry, we're almost done, you guys can come in. I didn't record who did well on, who solved search, and like most people did, I don't know, 90%, something like that. But I would need to have, whether or not you know search, I agree. If you got it on the midterm, you understand search and the alpha beta. But I didn't record that information. So you'd have to produce your test and show that I got search. Otherwise, I don't know that you learned it. Just because you got 40 out of 50 on the quiz doesn't mean that. Well, if you did that.
That's optional. I mean, you can stick with your own grade. You know what I mean? Or you can take the first half of the final if you want.
Oh, I see. So basically, if you don't do the first half of the final, then your quiz grade gets repeated.
Yeah.
Can you just pick the better of the two?
We already had this agreement about picking the better
It
of.
seems like
What was the agreement about for how
the
to?
quiz weren't double or the finals weren't double?
You're gonna absorb the whole
Trevor
file.
helps you get one.
The finals either were 30% or 20%.
Yeah, it
But
was
quiz
always
we had
20
a
quiz or
quiz.
yeah.
I'd just rather focus on like, okay, that works in HLM rather than, working research,
But I still have to produce the quiz for those people who didn't do well on.
You'd have less to grade for most of the people.
What if you make the search column extra president? So those who choose to do it can use it to make points elsewhere. While those who don't want to don't have to take them.
It would have to be more like you either, like your score gets doubled if you only do the new stuff, then that becomes weighted twice as much. Yeah, so people who are like not as sure of the new stuff should study for the old stuff too, so they'll have those points in the bank.
So 15 multiple choice on search, and then 15 multiple choice on the new material.
I'll see if I can do some multiple choice ones. That would make me happy too. I will have more multiple choice than I normally do, but they will be the type where if you answer wrong, you're penalized.
Yes, you better off skipping. Just guessing.
Yeah.
I just got a text message.
Options are better off guessing.
Right, if you can eliminate one option, you should guess.
Yeah.
Yeah, just like on an SAT.
Some of them punish you so much that you have to work guessing because you know the answer.
Oh, well, that's not right either.
Yeah, can we just say that this is the test bank that you're pulling from?
No. Well, you get 3 pages of notes. Yeah, 3 pages.
Whoa.
When that happens,
Oh,
Just now.
Is there anything going to be on Minsky?
No.
do the notes have to be handwritten?
Yes, the notes must be handwritten.
Is it green double-sided?